I just realized that, oh no, this is plugged in. Okay, good. Lesson 63, we're good. Changing rates. Okay, so you guys, we've done unit rates and unit multipliers, but we haven't done changing rates, so it's pretty easy, but just watch. So if 30 jars can be filled in 1 minute, then we can write that two ways, right? So go ahead and write that down. 30 jars over 1 minute, or 1 minute over 30 jars, right? We flip them for whatever we're multiplying by.
Wait, should we write that?
Yeah. Okay, so we want to keep it like this most of the time when we're writing our rate. We pretty much are going to say it like this, 30 jars in a minute. We only need to flip it if we're multiplying by something. So if we double the rate, we're actually going to multiply the numerator by 2, okay? When you double the rate, you multiply the numerator by 2. So that means that I can do 60 jars in 1 minute, right? I'm doubling, I'm going twice as fast. So keep the denominator the same, right? If I do 60 jars in a minute, that's twice as fast as 30 jars in a minute. Okay? And we could also write this, of course, the other way. Okay, so doubling means times by 2, just numerator. And what if we increase the rate by 7 jars per minute? So if I increase the rate by 7, increase means, yeah, we're going to add, okay? So if I increase the rate by 7, that means I can do 37 jars per 1 minute, okay? If I was doing 30 jars a minute and I increased by 7, now I'm doing 37 jars a minute. And then we can write this, of course, the flipped way. Yes, Randy.
Oh, wouldn't you also double the denominator?
Let's think about that. Let's say you doubled the denominator, and now you're doing 60 jars in 2 minutes. 60 jars in 2 minutes. Did you increase your speed? No, those are equal to each other, right? Because now 30 jars, if you reduce it, it's the exact same thing. You didn't increase anything. It's the same number. Make sense? Okay. Yeah.
It also says it's 30 jars plus 1.
Yes, it does. But you don't want to multiply by 2 over 2, because that's multiplying by 1, which doesn't change value. So you just want to multiply by 2. Okay? All right. So Jim drove the 120 miles to grandmother's house in 3 hours. He increased his speed by 10 miles per hour on the way home. How long did it take him to drive home? So we're going to bring back the dirt triangle for this problem. Okay? Yeah, so draw a really nice triangle. Hopefully it's as good as mine. And if you guys remember the dirt triangle, D goes on top. Rate times time, because distance equals rate times time. And then you got to put your divide signs in case you're solving for R or T. Okay, so Jim drove 120 miles. So 120 miles represents which one of those variables? Yeah, the D. Okay, 120 miles is the distance. And 3 hours represents which one of those variables? The time. So we're missing the rate, and we want to find it. Okay, we want to know how fast we actually went, the rate. So the formula for rate, Devin, would be what? Very good. You got to write the formula down, right? I need that every time. And then we're going to plug in the distance is 120 miles, and the time is 3 hours. Okay, so if I went 120 miles in 3 hours, that's 40 miles per hour. Now, we got to show this step. So this is a change of rate. That's the title of the lesson, right? So he increased his speed by 10 miles per hour. What am I going to do to find my new speed? Ready? What? Anyone want to help him out? Right. We want to add 10. So my new rate is 50 miles per hour because it said he increased his speed by 10 miles per hour on the way home. Now, there's 2 parts to the problem, right? We had to first find the rate, my initial rate, and I had to add the 10, And now I have to answer the last question. How long did it take him to drive home if he's going 50 miles per hour? How long did it take him to drive home? How long means what variable?
Time.
Time. So T Hansa is equal to what? What formula?
Time equals distance divided by rate.
Time equals distance divided by rate. Good. Okay, so the distance stays the same, right? We went to Grandma's house and we went home, so it's the same distance. So the 120 miles stays the same. But we changed our rate on the way home because we're going 10 miles per hour faster. So now we're going 50, so that's what we plug in for R. Okay, we cancel those and we get 10, just kidding. We get 2 and 2/5 hours. Or if you would like to write that as a decimal, you could put 2.4 hours. All right. One second, write this down. I'm recording. All right. So here we go. Margot could pickle 500 cucumbers in 2 hours. I know. Yeah.
What?
She's turning cucumbers into pickles. All right. 500 cucumbers in 2 hours. She got tired and reduced her rate by 1/2. How long would it take her to pickle 2,000 cucumbers at the new rate? So this one's not a distance rate time problem. We're going to use unit rates, all right? So the first thing we want to write down is 500 cucumbers over 2 hours, and we want to always reduce, okay? So we can pickle 500 cucumbers in 2 hours. We want to work with easier numbers, so we're going to reduce, okay? Always reduce, because we want to work with easier numbers. So if we reduce it, that would really just be 250 cucumbers in 1 hour, okay? Okay, she got tired and reduced her rate by 1/2. Who knows what to do now for reducing the rate by 1/2? Autumn, what do you think?
Dividing the numerator by 2.
Yeah, if we're reducing by 1/2, we're really just multiplying the top by 1/2 or dividing it by 2. We're doing half the amount. So half of 250 is 125 cucumbers per hour. Okay. That is a rate, which means we can flip it and write it either way, right? We could also write this as 1 hour over 125 cucumbers. Ran out of room, okay? So either one. All right, so we find our initial rate, we reduce it, and then we double it, or we triple it, or we half it, or we increase it by whatever, because we're changing it, right? Because this title is change of rates. And then we got to answer the last question. How long would it take her to pickle 2,000 cucumbers at the new rate? Start by doing 2,000 cucumbers over 1. Do not skip this step. Whatever they ask for, put it over 1, all right? And then use the rate to figure out your answer. So I want to know how long it's going to take me to do 2,000 cucumbers when I can do 125 in an hour. Which one of these rates should we use, you guys? The first one or the second one? Right, the second one, because we need cucumbers in the denominator so they can cancel. So 1 hour over 125 cucumbers, okay? And then you want to cancel that lovely word. You guys have done this before, many times. Just haven't changed the rates, okay? All right, so 2,000 divided by 125 is 16, and we get 16 hours. Okay, we got one more. Raul ran 6 miles in 2 hours, and then he ran 20 miles in 4 hours. By how much did his rate increase? This is another dirt problem, okay? So start with the dirt triangle, and we want to find 2 different rates. So miles is which of those variables? Distance. Hours is which of those variables? Time, okay? And if I want to find find the rate just for the first part, the 6 miles in 2 hours. We first need the formula for rate. So Ben, what's the formula for rate? Very good. Okay? So I'm going to plug in 6 for the distance and 2 for the time. And you get 3 miles per hour. Okay? And then we have another rate. So then he ran 20 miles in 4 hours. Same thing, we're finding another rate. So we need another formula. This time, Tim, what's my distance?
Distance 4 miles.
Good. And what's my time?
4 hours.
Good. We get 5 miles per hour. So even though he went further, he still did it at a faster pace. But the question really says, by how much did his rate increase? What are we going to do to find our answer? What did you say?
5 minus 3.
Very good. Subtract. I just want to get that on recording. 2 miles per hour. All right. That's it. Any questions?